beginning. Well, when we go back to the beginning, this is an important difference between, in my mind, science and, say, religion. When I go back to the beginning, I go back to as far as I can extrapolate my understanding of the laws of physics. Talk a lot about it, but it's not more than talk, in my opinion, right now. But very shortly thereafter, after that time, there's no reason to suspect that the current laws of physics don't describe what happened in the history of the universe. And again,
so as soon as it comes into being, the laws come into being as well.
Yeah, well, in fact, in the universe of nothing, I suggested that's certainly a possibility. Maybe they pre-existed, maybe they don't. Those are metaphysical questions. But what I did show in that book, which is fascinating to me, and the fact that 30 years ago we wouldn't have even been able to ask the question, much less answer it, is that it's quite likely that our universe could and did spontaneously arise out of nothing. No space, no time, and maybe no laws. And if you ask, what would be the properties of a universe today, 14 billion years later,
we're still estimating the birth of about 14 billion years ago.
13.8, yeah. Now, if you actually look at the numbers, which we can measure, we now know that number, 13.8, to an accuracy of, plus or minus maybe a 100 million years or two. 13.75, I think, is the most recent number. And it's amazing, the fact that you can get beyond one decimal place in cosmology is just remarkable. And it really is a testament to the developments. When I was even a young assistant professor at Yale, I remember talking to an older colleague who said that nature would always conspire decimal places. It's really a transformation, and one we're celebrating, which is what I tried to do in that book.
We have armed objective.
But the early picture, the fact that we evolved from a Big Bang is not in dispute. Let me make that clear. The Big Bang happened, just like evolution happened, and the Earth is round, and there's no doubt that the early history of the universe was a hot Big Bang. There's no doubt the history of the universe, that's called the horizon. In analogy with the Earth, when you look out at the Earth, you can, when it curves, you can only see out to a certain distance. And we call the causal horizon that region with which light could have traveled to interact with us since the beginning of time. And
that's the universe as far as we're concerned, because nothing outside of that can affect us in any way.
Exactly. So operationally, it's a much better definition of a universe to be that which we can be causally affected by. And so, and because that changes with time, that's what is our observable universe changes with time, and we'll get to it because things have changed a lot, and it followed a random walk. It wasn't free to travel because all the universe was charged and light would interact and bounce off things. But at a certain point, when the universe was about 300,000 years old, matter became neutral. Protons captured electrons to form hydrogen for the most part, and neutral matter doesn't interact with light as strongly as charged particles. And that meant that radiation, which was kind of trapped early on, when the universe was 200,000 years old, could suddenly travel freely through the universe without really interacting. And when we look out, basically we see space, and the light, could travel and travel. But if we're looking back further in time when we look out, and if we look out in that direction, back to a time when the universe was 300,000 years old, we're kind of sort of going to see a wall, if you wish, because we can't see before that time because the light, couldn't have propagated out, just like it can't propagate out through a wall. Only from the surface of the wall can we see it. And of course, so what we're looking at depends upon where we are, so that if we were doing the same experiment on an intelligent species in another galaxy, located 100 million light years away, we'd assume the older the universe, the longer we live, the older the universe is, the more we'll be able to see, right? Because light can travel further.